WM is not a technology company, but it may be quietly building one of the most automated physical networks in America. It started with AI and robotic sorting inside recycling facilities, where WM says automation is already delivering a sustained 30% improvement in labor cost per ton versus legacy plants. But now the story is moving much further. WM has successfully piloted remote-controlled heavy equipment at its Arizona landfill and is working with Caterpillar to test autonomous landfill equipment. This could change far more than recycling. If automation eventually spreads across WM's facilities, trucks and landfills, the real opportunity may be a structural shift in productivity, turning one of America's most labor-intensive businesses into a far more intelligent operating network. Waste management looks simple from the outside, but the business is built around a massive physical workforce. Trucks must be driven, materials must be sorted, equipment must be operated, and landfills must be continuously managed. WM operates roughly 20,000 trucks every day across North America and manages more than 260 landfills, creating thousands of repetitive tasks across its network. That makes waste management an unusually interesting target for automation. The opportunity is not simply to replace workers with machines. It is to make each truck, facility, and piece of equipment more productive. If technology can reduce labor intensity while increasing throughput and asset utilization, even small efficiency gains could compound across WM's enormous operating footprint. That is where the automation story really begins. The first major breakthrough in WM's automation strategy is happening inside its recycling facilities. Sorting waste is a highly repetitive process, traditionally requiring people to identify and separate materials moving rapidly along conveyor belts. WM is replacing more of that manual work with AI, optical sorters, and intelligent sorting equipment. The company says these technologies are designed to capture more recyclable material while improving the efficiency of its facilities. This is already being deployed at scale. WM's sustainability program targeted 39 recycling growth projects, with the network expected to add about 2.8 million tons of annual recycling capacity when completed. The important shift is that WM is not simply building larger recycling plants. It is building smarter plants that can process more material with less labor intensity. The most important evidence that WM's automation strategy is working is not the number of robots it has installed, it is the change in cost per ton. WM says its automated recycling facilities are delivering a sustained 30% improvement in labor cost per ton compared with legacy facilities. That matters because labor is one of the most difficult costs to remove from a physical waste operation. And the benefit is not simply fewer workers. WM's earlier automation projects showed that higher throughput and better material recovery can occur at the same time. In Houston, for example, an automated facility achieved a 33% reduction in labor per ton while increasing capacity by 75%. This suggests automation is changing the underlying unit economics of recycling, more tons processed, with less labor required for each ton. Automation is becoming more valuable because WM is not using technology simply to reduce labor. It is also using the same infrastructure to process more material and recover more value. WM's automated facilities are estimated to deliver 30 to 35% higher capacity and 10 to 15% higher blended value per ton versus non-automated facilities. Houston provides a real-world example. After consolidating two facilities into one automated operation, WM increased capacity by 75%, reduced labor per ton by 33%, and cut recyclable material loss to residue by 51%. That combination is important. The same physical footprint can process more tons, while better sorting captures more valuable material. If these economics can be replicated across WM's network, automation becomes more than a cost-saving program, it becomes a productivity and revenue quality engine. The important question is no longer whether automation works at one recycling facility. It is whether WM can replicate the economics across its network. And the scale is becoming significant. WM's sustainability program targeted 39 recycling growth projects, expected to add about 2.8 million tons of annual recycling capacity. By the end of 2025, WM had completed 25 of those 39 projects, with the remaining projects scheduled to bring the program substantially toward completion in 2026. More importantly, WM's June 2026 presentation shows that automation is being integrated into a much broader operating network spanning 51 single-stream recycling facilities, 482 landfills, and 129 million tons of solid waste managed annually. The strategic shift is from isolated automated plants to a technology-optimized national infrastructure network. The next major automation opportunity is moving out of the recycling facility and onto the road. WM operates roughly 20,000 trucks every day in North America, with about 15,000 dedicated to collection and recycling. At that scale, even small improvements in routing, vehicle utilization and driver productivity can potentially create meaningful operating benefits. WM says AI is already being incorporated into dynamic truck routing, fire prevention and driver safety monitoring. The strategic significance is that WM is beginning to treat its fleet not simply as a collection of vehicles, but as a data-driven operating system. Better routing can reduce unnecessary miles, while real-time monitoring can improve safety and operational decisions. The opportunity is not one breakthrough technology, it is the cumulative effect of making thousands of daily routes progressively smarter. Landfills may look like the least likely place for digital transformation, but WM is turning them into connected operating environments. Its connected landfill system uses internet-connected devices and sensors to give technicians real-time visibility into site conditions, equipment health and operating data, while digital dashboards allow teams to monitor and interact with equipment remotely. WM deployed 15 connected landfill sites in 2025, with further expansion planned in 2026. The technology goes beyond monitoring. Automated wellheads can continuously adjust landfill gas recovery in real time, while drones and advanced sensors provide more frequent data about the site. WM says these technologies can improve operational efficiency, reduce human exposure to hazards and optimize landfill gas recovery. The important shift is simple: the landfill is becoming a connected industrial system, not just a disposal site. The next step in WM's automation journey is no longer about sorting materials, it is about controlling heavy machinery itself. In August 2026, WM said it had successfully piloted technology that allows landfill operators to control heavy equipment remotely, moving the operator away from the machine and potentially away from hazardous working environments. The pilot is being conducted at a WM landfill in Arizona, using remote controls and cameras to operate equipment from a separate location. WM says the technology is designed to improve employee safety while also creating operational efficiencies. More importantly, remote operation creates a bridge between today's human-controlled machines and tomorrow's autonomous equipment. WM is now working with Caterpillar to advance that next stage. The machine is still being controlled by a human, but the human no longer needs to sit inside it. The next step is no longer just remote operation. WM and Caterpillar are now testing autonomous heavy equipment inside an actual landfill environment. After successfully piloting Cat Command remote control technology at WM's Marana, Arizona landfill, the companies are moving to test a Caterpillar-developed autonomous landfill compactor. This is important because it represents a progression from human-controlled machines to systems capable of performing tasks with far less direct intervention. WM says the broader objective is to improve safety, efficiency, and productivity, while developing additional autonomous solutions for landfill operations. But this is still a test, not a commercial-scale deployment. The investment implication is therefore not an immediate financial forecast. The real significance is that WM is establishing the technological pathway from connected landfill remote control autonomy. If that pathway works, the landfill could become one of WM's next major productivity platforms. WM's automation opportunity becomes much more interesting when you look at the scale of the network. The company runs about 22,000 collection drivers and 19,000 average daily routes, while its fleet drives roughly 555 million miles annually. WM estimates that just a 1% improvement in efficiency across its collection business could generate approximately $30 million in annual savings. That is the power of scale. Automation does not need to transform every operation overnight to become economically meaningful. A small improvement in routing, vehicle utilization, equipment productivity or labor efficiency, repeated across thousands of daily operations, can compound into substantial savings. And this is only the collection network. WM also manages more than 120 million tons of waste annually across more than 260 landfills. The real opportunity is therefore not one breakthrough machine, it is the cumulative economics of making a massive physical network incrementally smarter. The real question for WM is no longer whether its automation works. We already have evidence that it can improve recycling productivity, and WM is now extending technology into routing, connected landfills, remote operations and autonomous equipment. The harder question is whether these individual improvements can compound across the network. WM operates roughly 20,000 trucks a day, manages more than 120 million tons of waste annually and operates more than 260 landfills. That scale creates enormous potential, but also enormous execution complexity. Management itself describes autonomy and remote operations as a phased approach, which means the technology will take time to mature. If WM can successfully connect these systems, the payoff could be structural: lower labor intensity, better asset utilization and higher productivity across the network. The technology is interesting. The scalability is the thesis. WM's long-term opportunity is no longer simply about collecting more waste. It is about making the entire physical network progressively smarter. The transformation is already visible. Automated recycling facilities are improving labor efficiency and material recovery, AI is being applied to routing and safety, connected landfill adds sensors, data, and remote monitoring, and WM is now moving from remote-controlled equipment toward autonomous landfill technology. Its June 2026 investor presentation describes 51 single-stream recycling facilities, 482 landfills, 38,000 landfill gas wellheads and 129 million tons of solid waste managed, increasingly optimized through technology and automation. The ultimate thesis is therefore bigger than AI. WM is building a connected operating network where software, sensors, machines, and people work together to make a massive physical business progressively more productive. As always, this video is not financial advice. Please do your own research before making any investment decisions. Thank you for watching. If you found this analysis helpful, don't forget to like, subscribe, and I'll see you in the next equity research.